proving identities. Honestly, I think proving identities is a little bit easier than what we just did because you can see what you're trying to make the equation or what you're trying to make this expression equal. You kind of have an end goal in mind. It kind of gives you some direction. But I have seen questions, I've seen release questions that just ask you, what trig identity could be used to simplify this expression. So obviously, with a multiple choice test, they cannot test you beginning to end on simplifying or proving a trig identity, but they can ask you, well, what would you use to simplify this? What would you plug in to be able to prove this trig identity? So let's look at this first one here. We've got the tangent of theta over the secant of theta is equal to sine of theta. You usually want to pick the side that looks more complicated or that has more stuff to it. So in this case, we're going to work on the left side of the equation. Now, here's the thing with the trig identity. It looks like an equation. It is an equation. We're not trying to solve here. We're not looking for what theta is. And we are not allowed to move things from side to side. Okay, let me repeat that. You are not allowed to move things from side to side. So once you pick a side to work on, you're stuck. Like that's all you can do. You can only work on that side. You cannot touch the other side. So with that left side, those are both can be rewritten in terms of sine and cosine. So let's start with that. Tangent is sine of theta over cosine of theta. Secant is 1 over cosine of theta. And this is, our goal is to make this equal sine of theta. Now, it's not going to be too difficult in this case because we've got a fraction divided by a fraction. So the top one stays, the bottom one flips. The cosines cancel, and we get sine of theta, which we're supposed to get. And yes, I know it looks incredibly redundant, but that is supposed to be your last step. Sine of theta equals sine of theta. You've got to show that you get all the way to the end and that it's equal to the other side. Okay, let's look at number 3. Cosecant of theta is equal to cotangent of theta over secant of theta plus sine of theta. Obviously, the right side here looks like there's more stuff that we could do to it. So let's leave the left side as cosecant of theta. That is our ultimate goal. Let's start like we did just the previous problem. Rewrite cotangent so that it's cosine over sine. And rewrite secant so that it's 1 over cosine. You may want to separate your notes papers so that you can see the identities that were on the very front page. That may be helpful to you. Okay. So we've got a fraction over fraction, so we'll handle it like we have been. Flip and multiply, but this time it doesn't cancel. Nothing cancels. But we do have some like terms. Cosine times cosine is cosine squared. Now, our goal is that this should be equal to one single term, cosecant of theta. Right now, we're adding a fraction and something that is not a fraction. So to be able to combine a fraction with something else, what do we have to have? What do you have to be able to add a fraction to anything? Think numbers. If you're trying to add 1/4 and 1/2, what do you have to have? Common denominator, right? We need a common denominator here. Sine doesn't have a denominator. It needs a denominator of sine. So we are going to multiply it top and bottom by sine of theta so that it has a common denominator. Well, when we've done that, sine times sine is what? Sine squared. Now, I've run out of room. Hopefully you're writing a little bit smaller than I am. So I'm going to have to go up to the top over here. Now, if you can do this in fewer steps, Absolutely. I'm just trying to be as clear as possible right now as to what's happening. So sine times sine is sine squared. We have a common denominator, so we can add their numerators. So cosine squared plus sine squared over sine of theta. And cosine squared plus sine squared is 1. And 1 over sine of theta is cosecant, which was what we were supposed to have. It was supposed to equal cosecant. Now, ideally, you just have one big line here going straight down. Obviously, I ran over it. There was not enough room in the box for the work, but okay, let's look at number 5. Obviously, the right side, again, is the side that we're going to be working with. So we've got cosecant of theta times cosine of theta over tangent of theta plus cotangent of theta. Now, when we had this before, we multiplied by the conjugate. So tangent theta minus cotangent of theta. I would not do that in this case because if you look at your Pythagorean identities, tangent squared and cotangent squared, they don't go together. Okay, they are in separate Pythagorean identities. So that's not going to do us any good. So the way that I would start this problem, and to be honest, sometimes proving trig identities is a little bit of trial and error. Sometimes you're going to have to go back and you're going to have to erase your work. You're not going to get it right off the bat every single time. Okay, so let's see here. Cosecant is 1 over sine. Cosine, we'll leave it the way it is. I was just thinking there for a second, since that's cosine over sine. Just trying to decide if we do need to multiply by the conjugate. Actually, yeah, I think we are. Let's try it. Okay, so what I saw when I replaced cosecant with 1 over sine is I see that numerator can be written as cotangent of theta. And now we've got all these tangents and cotangents. So I am going to multiply by the reciprocal. Top and bottom. Did I say the reciprocal? I'm in the conjugate. Okay, we're going to multiply by the conjugate. So cotangent times tangent, those are reciprocals. Cotangent and tangent are reciprocals. So when we multiply that there, that's going to be 1. Cotangent times cotangent is cotangent squared. And in the denominator, we've got tangent squared of theta minus cotangent squared of theta. Okay, it may not look like we've gotten very far, but we're getting there. 1 minus cotangent squared. 1 minus cotangent squared. Like that. I was thinking that was one of the Pythagorean, and the cotangent squared plus 1 is the Pythagorean identity. So you can't put that in. So we're not going to erase what we've got. We're going to keep it. We're just going to try something different. Let's rewrite cotangent so that it's cosine over sine squared, obviously, since it's cotangent squared. So it's cosine squared over sine squared. Tangent squared is sine squared over cosine squared. Cotangent is cosine squared over sine squared. what we have here now is a complex fraction. We've got fractions within a big fraction. So if you remember, this is getting way bigger than I was hoping it would. Maybe we need to go back to that first step and do this. I know y'all hate it when I do this, but showing you, trial and error. Sometimes that's all it is. Let's go back up here. All right, so going back up to the beginning, that first time that I replaced cosecant with 1 over sine, and replace your tangent and cotangent with sine and cosine. Okay, we've got a complex fraction here, so let's deal with that. Okay, remember how we handled complex fractions? We multiplied, let me use a different color. We multiplied by the denominators, right? So we've got sine of theta, so we multiply everything by sine of theta. We also had a denominator that was cosine of theta, so we multiply everything by cosine. Remember doing this? We didn't do it with trig at the time, but we did it with variable expressions. So in that first one, the sines cancel, so cosine times cosine is cosine squared. Here, the cosines cancel, so sine times sine is sine squared. The sines cancel, cosine times cosine is cosine squared. And this got us somewhere. Sine squared plus cosine is 1. That denominator is equal to 1. What did we want this to equal? Cosine squared of theta. Okay. This is the first time that I've looked at these problems. I did that on purpose to show you that sometimes you're going to have to try something and it's not going to work, and you're going to have to go back and you're going to have to punt and you're going to have to try something else. There's absolutely nothing wrong with that. It's math is trying something, seeing where you get, and then trying something different. All right, so let's look at a couple more. Let's see here. And find one that looks like I'd have to do something more. Let's look at number 9. Secant squared of theta is equal to cosecant squared of theta over cosecant squared theta minus 1. Now, I know it's so tempting to just cancel those cosecant squares. You can't do it because of that minus 1 in the denominator. But since we do have a trig function squared and a 1, I would think Pythagorean identities. When we look at Pythagorean identities, look at the last one, cosecant squared. You can subtract that 1 and it's equal to cotangent squared. So let's replace that. Cosecant squared minus 1 is equal to cotangent squared. So we've done the Pythagorean identity method. Let's change everything to terms of sine and cosine. Cosecant is 1 over sine squared. Cotangent squared is cosine squared over sine squared. We have a fraction over a fraction, so we keep the 1 on the top the same. We flip the bottom one over. The sine squared is cancel, and 1 over cosine squared is equal to secant squared. Now, I've run out of room on the last few. I haven't been able to really write this. I'm fine if you just draw an arrow down that side, or if you want to write the secant squared of theta all the way down the left side. Technically, that's the more mathematically correct way to do it. one more. Let's do number 12. Number 12 looks a little bit more complicated. So on number 12, we're going to work on the left side here. And I'm thinking we need to turn our cotangent and tangent into terms of sine and cosine. So cotangent is cosine over sine, tangent is sine over cosine. Now, technically, this is a complex fraction. I'm going to handle this one a little bit differently, though. I'm just going to get a common denominator in the numerator. Okay, I'm just going to get a common denominator in the numerator. So I need to multiply the first fraction there by cosine over cosine. I need to multiply the second one by sine over sine, so that both of my denominators have sine and cosine. So cosine times cosine is cosine squared of theta, and that's over sine of theta cosine of theta. Sine squared times sine squared is, or excuse me, sine times sine is sine squared. And that's over sine of theta cosine of theta. We can then combine there in the numerator. They have like denominators, so we can just combine their numerators. And that's still all over sine of theta cosine of theta. Now be careful here, you cannot just cancel those sine of theta cosine of thetas. Go ahead and make that bottom one, it's not a fraction right now, put it over 1 so that it is a fraction. So fraction divided by a fraction, keep the top the way that it is. Flip the bottom one over. So the bottom one is now 1 over sine of theta cosine of theta. It looks like we're not getting anywhere, but we are, I promise, slowly but surely. Now, when we multiply, we've got sine cosine times sine cosine. So sine times sine is sine squared. Cosine times cosine is cosine squared. Now, let's take a quick glance back at the beginning. You need to look back to the beginning every once in a while to see what your end goal is. What am I trying to make this equal? Okay, this is supposed to end up being cosecant squared minus secant squared. So the good news is we already have a minus in there. Okay, that's part of what we need. But right now we've got cosines and sines. We need secants and cosecants, and we don't need a denominator. Now, since this denominator here doesn't have an addition or subtraction in it, we can decompose this fraction. Okay, what that means is that you are pulling it apart. You can put the terms of the numerator over the denominators. Okay, it's like you're going backwards. Instead of combining the fractions, you're pulling it apart to what produced the fraction. So I put the numerator, cosine squared theta over the denominator minus sine squared over the denominator. Notice that they have the same denominator. I can just put their numerators together and I'm right back where it was. But what this has done is, look, now I can simplify this. Cosine squared over cosine squared, let me change colors so you can see. Cosine squared over cosine squared, that cancels. 1 over sine squared is cosecant squared. In the second one, the sine squares cancel. 1 over cosine squared is secant squared. And that's what we are supposed to have. Cosecant squared of theta minus secant squared of theta. So some of these trig identities take like 2 steps. Some of them require a few more. Sometimes you can tell from the beginning, sometimes you can't.